All right, let's start. Hello, everyone. This is Dr. Yuzo. This is our ECE318 Electronic Circuit 1. Today is our 24th lecture, December the 1st. And from the Gantt chart here, you can see we are at this very cell. Homework 5 is due today. All right, let's step into the lecture slides. So first of all, we are watching the small signal model of the BJT. So this is the page 7 of the slide 20 from last lecture. Okay, that's the most important slide page. You want to print it out. Of course, also put the PNP small signal model on it, right? Because there here is only NPN. So you want to put the PNP on the same page as well, okay? Put them together so you won't miss the difference, okay? And the three small signal analysis parameters equations listed here, okay, right? 3 this time, okay? We have 3 because back in the MOSFET, we only had 2, right? So now we have 3, and we have 3, okay? So everything in AC analysis actually begins with this, right? You need a circuit, and the circuit begin with the small signal model of the transistor, and then extending the circuit terminal by terminal, right? That's why this is so important. It's so important. You want to use this as a handout, print it out, have it ready all the time. Okay. And here is also kind of a review because we presented here this small signal analysis procedure by the end of last lecture. Okay. And let's see what we have, so-called the arsenal. See what weapon we have. So always remember DC analysis goes first, since AC analysis requires a DC result, right? And then in the AC small signal analysis, what do we need to do? 3 things, right? 3 steps, basically. First one is calculate the small signal parameters. Okay, we just mentioned 3 of them. Okay. Second step is do the circuit, find a circuit. Okay. How to find a circuit? Everything is regular, right? I'm removing the DC source. Short the capacitors. Of course, be very careful. We have 2 types of capacitors, coupling and bypass, right? And the bypass is a tricky one, right? Bypass is very meaningful name, right? Because you short it, it might bypass something in parallel. Does it make sense? So be very careful, okay? And then first place the small signal model, and we just discussed this as well, right? This small signal model of the transistor right in the middle of your paper, and then extending the circuit terminal by terminal, okay, terminal by terminal, based on the given circuit, okay, based on the given circuit, which means you're not relying on your memory, you're not relying on your imagination, okay, you're relying on whatever is given, because the given circuit might be various look, right? We have so many options. We have so many possibilities. Okay, so you're reading the given circuit, and then accordingly come up with the small signal circuit. Okay. After having the circuit in this step 2, we go ahead to find the AC gain. Okay, AC gain. And then we have these weapons to use. First, output equation. Okay, this is similar to the MOSFET. Output equation, generally speaking, is actually Ohm's law. Just to be careful, what's the current and what's the resistance, right? Second, you have relation between the input AC source and the V pi. Now, V pi is also VBE or VEB, depending on the type of BJT. Here, you might consider to use voltage divider, or you might consider to use the V pi loop KVL and or KCL at terminals. So you need to see what kind of circuit can you use the voltage divider, because sometimes you cannot, right? Next, we probably also need to be aware, be careful. The V pi, which is VBE, is equal to voltage at base with respect to the ground minus the voltage at emitter with respect to the ground. Okay. So be careful on this relation. It's something might be useful. And of course, as in the MOSFETs analysis, you need to count. You need to count. Okay, how many equations you have and how many unknowns you have. If your number of equations is one less than the number of unknowns, then you're good. Okay, that means you're good. And then you're able to find the ratio between any two unknowns. And what we need is the ratio between the output voltage and AC input source voltage. Okay, equals to the voltage gain. Okay, equals to the voltage gain. This is the procedure. With the background and experience from the MOSFET, there's nothing difficult here to you. Shouldn't be. But we still need to go through examples. Okay. Because first of all, I think I'm done theoretical teaching, and let's just do something. Okay. Have your handouts ready. If not printed out yet, okay, open your last lecture slides and then go to the page 7. You need that page, okay? And then have your pen or pencil and the paper ready. Let's go for some exercise, okay? The first one here is a circuit, a very simple circuit. You might want to do some identification at the first place. So first of all, this is an NPN or PNP? NPN. Okay, first of all, NPN. No, is right. Okay. Why is NPN? Because the arrow is from pretty much, this is what? This is base, right? Towards, what is this? What is the terminal? This terminal is what?
The emitter.
Emitter, right? So it's from base towards the emitter. And here is the collector, right? So from base towards the emitter, this arrow direction is telling us this is NPN. Yeah, this is NPN. NPN. And also, this is common what? Of course, without reading the title of this page, right? The common what? Common emitter, right? Common emitter. Why is that? Input as base, output at collector. Okay. Once again, input and output here refer to what? AC input and AC output. Okay. Be clear on that. Okay. This is common emitter. So after these identifications, give you guys 2 minutes to find the circuits, small signal circuits. Place your basic model in the middle and then find the total circuits. Go ahead, 2 minutes. All right, let's see the solution here. Okay, compare with yours on the paper. How about this? Take a look. Well, here, if you forget to involve the R0, that's not a big deal, because in the exam, you're going to be clearly notified. Okay, so just read the problem carefully. The problem is telling you whether you need to involve the R0 or not. Okay. So pretty much this portion is what? Basic model. This portion is basic model. Containing inside of the red color, well, I tried a square box, but it doesn't look like so, right? Anyways, this is the basic model, and we're extending the terminal by terminal. First one, which one is the easiest one? Sorry, I think I made a mistake. I shouldn't say this is the small signal model. This is the basic small signal model of the transistor itself. Does it make sense? More sense, right? So, and then we extending the terminal. So first, who is the easiest one? According to the given circuit, the emitter is the easiest one, right? It's directly the ground. That's why we have here. Emitter is directly the ground. Okay, we have here. And then followed by maybe the base. The base connect to R1, R2. Okay, R1, R2 are what? Parallel, because the other terminal of R1 up here is ground, right? It's ground. So here is shorted with the here of the R2, and here they're shorted together as well. So R1, R2 parallel. Base connect them and then short the input coupling CC and then connect to RS, and then further connect to VS, okay, just like this part. The collector is, first of all, is the output. Don't forget the output, okay? Your small signal circuit, you have to label where is the output. Okay, the collector is the output. Besides, the collector also connect to the RC and then further to the ground. Okay? So RC is between collector and the ground. Okay, no problem. But any questions regarding the small signal circuit? All right, if this is fine, then go ahead. Give you 3 minutes. Try to come up with equations.
And with the equations, we're including R naught?
Yes, please. All right, folks, let's see the solution here. So obviously, you can easily find the at least one output equation, right? And then try to build the relation between input source Vs and V pi, right? V pi is the voltage across the R pi, right? And not very difficult. This first example is not very difficult, like this, right? Output equation down here. Ohm's law. The current flow through R0 and RC are upward. Okay, be very careful. Current flow through R0 and RC parallel is upward, right? Therefore, establishing the output voltage like this, okay? Establishing the output voltage like this due to this current, okay? Which is opposite to the polarity of the labeled output. That's why you need negative sign here. Right? Ohm's law. And input side, we have, this is what? This is independent what? Single loop if you consider R1, R2, and R pi in parallel, right? The single loop, independent. So you can do what? Voltage divider. Very straightforward. You can do voltage divider here. So the 3 parallel divided by 3 parallel plus the series connected to RS. So here and here share the total voltage Vs, and then you find the voltage divider. And of course, you want to count. So what you have is 1 unknown, 2 unknown, and 3 unknown. Okay. 2 equations. So we are done. Okay. We are done. Enough for us to find out the ratio between output and input source. So take a look to see any questions you have. Okay, we can move on here. Here, another circuit with RE emphasized. So by neglecting R0, find a circuit by another 2 minutes. Go ahead. All right, let's see the circuit here, okay? Once again, neglecting the output resistance R0, and then we end up with such small signal circuit, okay? So the basic transistor model is obviously here. right? Without R naught. Okay, this is the basic model, and extending the terminal circuit by terminal by terminal. Okay. The emitter here is connect to RE. The other terminal of the RE is ground. Okay. Here we go. And the collector is output. Collector is up here. Output. And also collector connect to the RC. The other terminal of the RC is ground. Okay, here we go. And the base connect to R1 parallel is R2 and also RS and the VS. Okay. So basically the only difference from the previous example is the presence of the RE. Okay. So now the emitter is not ground anymore. It's not ground anymore. Any questions? Make sure you're really doing the exercise, okay? No better way to study, to prepare the material, okay? No better way than doing it in real time with the instructor. All right, if this is fine, then 3 minutes to find out the equations. Go ahead. All right, let's talk about the solution. First, I'm receiving a question, and two is asking, could you do V equals to V pi plus VE? The answer is yes. Okay, this is the KVL inside of this loop. Okay, we have done this, or say we have done something similar back in the MOSFET circuit. Okay. Of course, you need to take care of the VE, right? You need to take care of the VE. So let's see the solution. First, this is the easiest one, the output equation, Ohm's law, right? Now, current flows through RC itself, and you have a negative sign there. Okay. And then I'm doing a voltage divider. Right? I'm doing a voltage divider to find VE. And it's further equals to V pi plus VE. Right? So this part is VE. Any questions? Very good. I receive a good comment from Kevin. What is wrong?
In your voltage divider, you should also be paralleling the sum of R pi plus RE as for your R1 parallel R2.
Well, close, but not exactly right. Okay. So everybody listen carefully. Okay? This is kind of important. Okay. So first of all, look at the screen. Okay. Look at the screen. Okay. One more time to make it impressive. First of all, absolutely not right. Okay. Where is wrong? Okay. Voltage output equation is correct. This V in equals to V pi plus VE is correct as well. However, your voltage divider is wrong. Okay, Kevin was right on this. However, if you want to use this voltage divider, Kevin's solution is not right. Okay, listen carefully. If you want to do this voltage divider, you understand VS is sharing the RS, RS is sharing the VS with whom? Not R1 parallel with R2, but not R1 parallel with R2 and R pi plus RE either. But what? RS is sharing VS with the entire thing here. Does it make sense? You cannot only involve R pi and RE here, because we have connection here, right? connection here with this dependent source cannot be ignored. Okay, so if you really want to do this voltage divider, you want to do RS parallel, not parallel, RS series with this entire thing to share the total VS. Did I make this clear? Everyone?
Yep, I think so.
All right, thank you, Shane. How about others? Thank you, Kevin.
Yeah.
All right, thank you, Connor. Anyways, this is a voltage divider. Okay, it's a big, and therefore, obviously, this is not the best choice for us to come up with the equation. Okay, because the entire thing is not resistance only, right? And you can't easily find the equivalent resistance either, right? So we don't want to use the voltage divider. So keep thinking, folks. Anyone can propose any better equations instead of this? Because this equation and this equation are good. And actually, okay, I'm writing in this way is actually presenting you the solution already, isn't it? So these two equations, the V in equals to V pi plus VE. And this V naught equals negative GM V pi RC are two correct equations. Very good. I agree with Kevin's idea. KCL. KCL at where then? Base. Very good. Very good. Okay, very good. Very good. So let's all try Kevin's idea. Have an equation at the base KCL. Go ahead. Give you guys 1 minute. KCL at the base, which is nothing but here. KCL at the base. All right, let's see the KCL. How about this? This is nothing but the KCL at base. Does it make sense? And besides, this is the equation we just saw from previous page. Right, previous page. This is nothing but KVL in this loop plus the output equation like this. Because now if you count, you have Vs, V in, V pi, and the V naught. 4 unknowns, 3 equations. Very good. Does that make sense? So the key is the first equation here. Okay, you need to figure out instead of voltage divider, okay, you need a KCL. Well, I have emphasized this since the beginning of the semester. Okay, what you learn from 235 is you should establish such concept or say confidence that KCL, KVL, what always work, always work. However, current voltage dividers they don't. Okay. They don't always work. Okay. They have constraints. You need to be able to clearly identify a independent single loop or single pair. This is what we learned from 235. Okay, and be very careful when you use them. Any questions? All right, let me ask you guys. This guy here, we call it VE, right? Why is that? Why this is the VE?
It's the voltage at the emitter.
voltage at the emitter, that's correct. And how we find it, why it is equals to this.
Because that's the current going through the emitter times the resistance.
Very good. Okay. Kevin and Noah are right. So basically, we're using this Ohm's law. Okay, Ohm's law. The voltage across this RE as VE, no problem. Okay, and equals to what? RE times the current through the RE. The current through the RE is actually using what? Using a KCL at the emitter, isn't it? You're essentially using a KCL at the emitter. So looking for the current down here through the RE is actually equals to the current through R pi plus the current of the dependent current source. Okay, this is how we come up with the current through RE. And then this current times RE equals to V. Okay, I've been clear on this. So this second equation containing one Ohm's law, and which further contains a what? KCL. Does it make sense? And feel free to separate them, okay, when you write your equations. Any questions regarding this? All right, if this is fine, then we move on. This is the more formal example. I call it formal example because, as you see here, everything is specified with numbers, and also what you noticed. Looking for the small signal circuit and the AC voltage gain. However, you need to do what? DC analysis first, right? Does it make sense? All right, so I give you guys 5 to 7 minutes to conduct the DC analysis. So at least try to find the equations. Okay, at least the equations. And then if you do have enough time, find the results, find the values. All right, go ahead. DC analysis. All right, folks, so let's see the at least the equations here, okay? So DC analysis goes first. This is explaining why we are conducting the DC analysis first, right? So first of all, you are, again, not able to use the voltage divider between R1 and R2. Can't do this. So instead, you have to do a KCL at the base. KCL at the base. So the current is assumed to be like this. This current is what? IB, correct. And what's the direction of IB? Towards left, as I labeled, right? Why is towards left? PNP, very good, okay? Because this is the PNP transistor. Current at the base is leaving the transistor. Okay, very good. Okay, that's why we know the direction of the IB. So this is the resulted KCL. Any questions regarding this particular equation? All right, if this is clear, then we need more equation, obviously. What is it? KVL in what loop? VEB loop, right? VEB loop. We call it VEB loop. The loop containing VEB, not VBE, because this is, again, a PNP, right? So KVL inside of this loop. Okay, the top loop, that's correct. These are all the weapons provided in the procedure handout, okay, the page back in the DC analysis. Okay? Nothing beyond those. What else we need? Because now we have VB, IB, IE, 3 unknowns, 2 equations. What else we need?
Path KVL.
Path KVL, we can find it from top to bottom. Yep. We need path KVL. But never forget the basic current relations. Okay? We definitely gonna need them. And the bottom one, as Shane just mentioned, this is path KVL. Pos KVL. Right, from top to bottom, pos KVL. Now we definitely have enough number of equations. Yeah, we have enough number of equations. Actually, anyone, if you got the results, for example, IC, because we need IC for AC, right? Yep, Kevin's right. Kevin is got the correct answer here. It's about 0.56 milli. IB, as we mentioned before, is in micro. That makes perfect sense. Any questions regarding the DC analysis?
Yeah, so
Yep.
solving for IB, you just plug that in for the KCL. So you have the KVL equation, you solve for VB, and then plug in VB in the KCL equation and solve for IB.
I think you need to do some substitution because
Yeah,
there's no
part of it.
equation. There's no equation involving only one single unknown, right?
Yep, that makes sense.
Yep. All right. If this is fine, then what's the next? AC circuit and AC analysis, right? All right, go ahead. Find a circuit first. I'll give you guys 1 or 2 minutes. I will show this circuit solution, and based on which you guys can go further to find the equations and the resulted gain. Go ahead. So first of all, the circuit is like this. Right? The circuit is like this. What you need to be aware is, first of all, PNP, right? That's a PNP. And also, this is what? Common emitter. That's common emitter. Yeah, PNP, common emitter. And then we are using the PNP small signal model. Why we are not having R naught here? Why?
Because the early voltage is defined as very big.
Correct. Here is telling you R naught is infinity as well. That's why it's open circuit. Okay, that's why. And then we're extending the rest of the circuit terminal by terminal, ending up with this. Of course, due to the PNP, be very careful what the voltage polarity here, V pi. Voltage polarity here, V pi. And also the current direction of the dependent source. Right? And these are all on your handout. They're supposed to be. And if you know questions, another 5 to 7 minutes to do the AC analysis. Okay, equations and results. Go ahead. And of course, here I'm presenting since R naught is infinity, so we need to calculate the other two small signal parameters, right? R pi and GM. Okay. Now make sure they are correct here. Okay, these are two parameters, and based on which you go ahead for the equations. Let's see the equation. Okay, yeah, let's leave the result at last, but let's see the equation here. This is the first equation. The first equation, this is what? This is actually a KVL inside of this loop, right? KVL inside of this loop. Of course, be careful that the polarity of the voltage, right? The polarity of V pi is negative on top, positive on the bottom. And the voltage across the RE has also the same polarity like that. Okay, it's negative on top, positive on the bottom. Okay, so be very careful. Be very careful. And this is the case KVL in the loop, in the V pi loop, pretty much. Okay. Good. To get that equation as well. Okay, this is one equation. more, of course, this is the output equation, right? Output equation, which is very simple. It's positive, okay? So it is positive. So we have Vs, V pi, and the V naught. Well, guess what? We have 3 unknowns, but 2 equations. We are good. So if we go ahead to do the algebra, then it turned out that Noah is right. Okay, 91.93. Well, I think the design is bad. The design is bad. It's only even less than 2. This magnitude is low. But it is what it is. Okay, it's greater than 1. The magnitude is greater than 1. Okay. Now Kevin found his pressures. Flipped for the gain. Okay. And the Shane seems has not yet, but messed up the algebra. Okay. At least the equations are fine. Good. Any questions? Any other questions? Good. Very good. Okay, glad to see most of you guys are engaging. Okay. Definitely very helpful. Okay. Any questions? Any concerns? Okay. The polarity issue from Josh. Good. Okay. Find your pressures. All right. If these are fine, then we can move on. All right. Good.
Yeah, I figured out what I did wrong. I had the RE and RC resistors. I had the values flipped. So
okay.
That was it.
I see. Yep. Good. The RE is top here, right? Up here. It's at different location. That's right. All right. This is the example 1. For the example is only about circuit. Okay. Find DC and AC circuits for this given amplifier circuits. Okay. Only circuits. No equation. No calculation. Okay. So go ahead. 5 minutes. And then I will present the solution. All right, so presenting the solution for DC circuit first. It's fairly easy. You basically open all of the capacitors. Then they're gonna block the AC source. So the DC circuit is very straightforward, and based on which you can calculate whatever you want. And the AC small signal circuit is like this, right? So take a look to see how close or how far it is away from yours. Any questions?
Wouldn't RC be shorted? Or due to the short circuit, it's bypassed?
RC is down here. There is no bypass.
Oh, my bad. I was looking at the wrong thing.
Yep. RE is up here. Right? RE is up here. Going to be shorted by bypass C sub E. Yeah, this is another PNP. Yeah, you guys need to be careful which resistor is which resistor. Then the emitter is on the top, so that's why the connected resistor is called RE.
Yeah, I need to start writing names and not numbers because I'm getting the numbers backwards sometimes.
Or you can just writing numbers, neglecting the names. That's fine too, actually, as long as you know which resistor you're playing with. Emitter here is shorted to ground due to this capacitor. Okay, bypass. Same thing happened in MOSFET circuit. Any questions? All right, good. So thank you for attending today's lecture. See you guys on Thursday then. Thank you. Bye-bye.